Okay. Thank you. Yeah, that's actually a lot of people watch online.
Yeah.
Before I did that, everybody would come, and now people get that. They're like, I'll just watch
Yeah,
it at
it's
home.
online. It's like a YouTube channel or a
Yeah,
YouTube
yeah,
like
yeah.
live
It's,
stream.
yeah, it's a YouTube live stream. Yeah. But we have a few people coming, so.
Cool.
Welcome to Three Thoughts Song. Thank you, all of you that are online, for being here with us. Thank you to Reese Lynn from Nona Media and Juan Santos from MS2 here in Lake Nona. We're grateful for the opportunity to do this show here in a live setting, and for the members of the live audience that always are loyal to us. And a special thank you to these two fine young men that are the co-founders of a company called Source. How are you guys doing today?
Doing well.
Doing good.
Thank you for having us.
Thanks.
So we have Derek and Mason. Derek and Mason, if you can take a couple of minutes each and kind of tell us a little bit about yourselves and your story. I know your story because I was here when you guys, I was a mentor here at the Accelerator program when you guys were here through the LEAD program. But why don't you, for the audience, give us a little bit of background on who you are and what is it that you do?
Sure. So I'll just start off with the intro. So my name is Derek Saltzman. I'm one of the co-founders and CEO of Source. Background is in material engineering and material science. Went to the local university, UCF, alma mater, go Knights, charge on. That's actually where I met my co-founder, Mason.
Yep.
Funny enough, it was my very first roommate in college. So I came from an aerospace background where I like to build rockets. He came from a background with planes, and we met each other the first day, and he said, hey, let's go tackle the world.
Yep. And I'm Mason Mincy. I'm the COO and co-founder at Source. And like Derek said, we met back in freshman year of college. My background before university was in aerospace engineering, so like drone design, airplane design, stuff like that. So pretty good match, I would say, the first day at school. And both of us had a ton of experience in engineering before we met. So when we met at university, we just pretty much decided, let's tackle the world of UCF in the engineering program. And we just did a ton of projects together, and we can definitely get into the details of that entire story and how we got to this moment today. But to make a long story short, we've worked together for 8 years now.
Yeah.
You know, so when they say you form a startup with your co-founder, you're married, that's pretty much the case, 100%.
Not only we work together, we live together, we eat, sleep, breathe, everything we do together.
Exactly. And I would say what was really the catalyst of what we're doing today is we started a business during college, our probably freshman, sophomore years when we started it. And we didn't really know anything about business. All we saw was a sign at the university that said win $75,000 to start a business. And we're like, all right, well, we know engineering and we know how to build products. Like, how hard can a business be? And very difficult. And we didn't really know what we were doing. But, I mean, nonetheless, we took a shot at it. We had a strong team of me, Derek, and a lot of our friends at the time. Our first business was manufacturing carbon fiber drone frames. So people who don't know or aren't familiar with carbon fiber, it's really strong, lightweight material used a lot in the automotive industry, aerospace industry. And we were making these drone chassis out of it. And we got some good success with that business. And I would say in the early days of school, grades went to the wayside a little bit because we were so focused on building the business. But it was a really great experience. We got to work with some really cool companies. We got to work with Red Bull. We got to work with the data center that worked pretty closely with Amazon. So it was a great first experience. But we could tell during the early days of university, it really wasn't what we wanted to work on long term. But I got our feet wet. And then Derek and I worked closely in research as well. So we had this first business. We were doing decently well in sales, but we wanted to decide where could we take the business next. And at the time, we switched our degrees from aerospace engineering to material science, which is what our background is in today. When we made that pivot in our degree, we also made the pivot in the business, where we said, okay, well, we know this stuff around materials and chemistry now. Can we start from that level and create new fiber technologies, composite technologies? But we had to learn a bit more, so we worked very closely in research in a group called the Composite Research Group.
Advanced Composites Manufacturing Center at UCF
Yep.
under Dr. Jihua Gao. He was our original professor. And essentially that's where we got our feet wet. That's where we got to learn all about kind of the more advanced side of material science. So think of nanomaterial processing. So if you're a material science or chemist, you've heard of the word graphene before. It's kind of the most ubiquitous nanomaterial. It's always 10 years away, still 10 years away today. But I mean, when we were working in these manufacturing settings in university, we noticed a kind of a key problem where, one, to manufacture these types of really advanced nanomaterials is, one, very expensive. Two, it was very costly and kind of toxic to do. So, I mean, if you saw us in the lab and we had gas masks, the bunny suit, the whole nine, if you were looking, so that was one of the big two key factors that we noticed is, like, one, the cost to produce these types of materials is very expensive, and two, the overall environmental impact and just waste management is quite high. And that's what kind of set us on the new path of, as we were kind of ramping down our first business, which was SOAR Aerospace, and kind of pivoting into Source is what we do today. And it kind of just led us to what we actually do today, where we're an advanced nanomaterial manufacturing company, where we take excess biomass, such as seaweed or hemp. We have a proprietary process that allows us to functionalize and extract out specific biocomponents from the seaweed and hemp, such as cellulose, which is the most abundant biopolymer on the planet. It's found in pretty much every plant. It's in the cell wall of every plant. So kind of going back to biology, where mitochondria is the powerhouse of the cell, we deal with the cell wall. And then essentially from these nanomaterials from nature, we take them and then we start incorporating them into a variety of market applications. So today we're working in aerospace settings, marine settings, energy settings, and essentially the way that it works is you take these nanomaterials and you dose them into, if you've ever been on a boat, fiberglass boats, it makes the boats lighter, stronger. Airplanes, again, similar situation, it makes them lighter and stronger. And even in energy settings right now, we're actually working with a couple companies where they're able to produce more energy efficient power generation utilizing lighter, stronger weight materials.
Well, that's quite a story there. So you guys, before you even, actually before you even graduated, I remember you having, you already were here at the accelerator with LEAD, and you were already talking to investors. You were already made that pivot that you just talked about, right? And at the time, I remember you were being focused a lot on materials, you know, from algae that could be derived from algae for clothing. Because obviously the LEAD accelerator, it was kind of focused on sports and health and medicine, and sporting clothes is kind of fits in that environment, right? So how was that experience?
Ooh, I mean, it was interesting because I think the upside of our experience at university, we got to work with the Blackstone Launchpad. So Blackstone has a philanthropic arm where they pretty much go into universities and they create curriculum for entrepreneurship. So we got our chops from that point. So we understood, I mean, we've done so many pitch competitions, we've pitched so many times. So we got a lot of experience from there. Yeah. But going through the LEAD program was definitely a step up that we weren't ready for at the time, but it's kind of just trial by fire, and it definitely was fire. It just made us realize there's a certain level that you have to perform at when you start to raise money, and then the expectations change. And I think it was a lot at once for our team, understanding what we were getting ourselves into and the business we really wanted to ultimately create. So to your point, during the time, you know, what we do today is not what we were doing when we first got into LEAD, like 2 years ago. We were trying to solve the issue around toxicity with clothing, because all the clothing that we wear is made of plastic primarily, or it's some natural fiber that's coated with a ton of toxic compounds that directly lead to respiratory issues, kidney failure, etc. So that was kind of our in LEAD. And during the program, I think the biggest challenge that we were trying to overcome as a team was, how do we go through this program that's maybe like 4 months around that time, and compartmentalize what we're trying to do as a business in those 4 months and try to gain traction. And I think at the time we were comparing ourselves to the startups here that were more focused on building, let's say, software startups. And we were building something with atoms, right? We were using chemicals. And we actually built a setup, you know, right in the back of LEAD to produce these materials, these fibers at the time from algae. And yeah, it was just a very interesting and challenging time because we had to really understand our business is not like most of the businesses here, where we have to build things up, we have to manufacture things. So it was just it was a learning experience to understand what it took to build a venture-backed business, the expectation with that, but also understanding like, hey, we're not like the other companies. We have to understand what are our KPIs as a business that we really need to work on, not compare ourselves to other companies here.
Yeah, a lot of the times, especially in the world of startups, you hear a lot about SaaS, you hear a lot about software as a service, and just the next best app or the next best AI software. Those types of companies, you're dealing with bits, ones and zeros. We deal with atoms, and it's quite challenging because you're trying to force nature to do things that nature doesn't necessarily want to do sometimes, which makes it a fun, challenging problem. And then too, I remember there was one time when we were building a wet spinning machine to spin algae fibers in a industrial space here, and I remember there was one day we put everything together and we had no idea if it was gonna explode, blow up, so we told everybody in the lab like, hey, come look at this and hold up shields just in case if this doesn't work, and the part goes flying through that window and if we don't break anything. So that was actually a really fun time just in the company's journey, seeing how you adapt and move. And I think one of the biggest things in a startup, and I think Bruce Lee said it best, is be water, flow like water, become the cup. And the main reason I say that is because you have to learn to adapt and adapt to the market, adapt to what your customers want, and adapt to what you're best suited, what your core competencies are as a company. At that time, we thought, yeah, algae fibers for sustainable clothing, replacing polyester, that was going to be the thing. And then as we started to get into the market and quickly realized just the overall immense challenge that it is, as well as just the demand, we realized that, well, maybe this isn't the best first market to start in. And hence the analogy to Bruce Lee and the be like water is we noticed like, oh, there's another area of just being a chemical company, of an algae-based chemical company where we produce these functionalized nanomaterials was a lot more advantageous for us rather than trying to be a finished textile good.
Just for the audience real quick, how old are you guys?
27.
26.
26 and 27. They talk like veteran entrepreneurs, which in some ways you are, right? Because you started so young.
Yeah.
No, it's very interesting what you're saying, because even within the domain of building things, so let's forget for a moment about software companies, and you look at hardware companies, even in that domain, you're still different, because you're not just putting something together that's going to be a box. You need a wet lab, right? Which is a very specific environment to be able to run very specific tests on their specific, let's call it atmospheric conditions, if you will, you know, with particles per million or per billion or whatever, right? So it's still a departure from a standard hardware company.
Yeah.
Correct.
So did you experience any level of success? I was personally excited when you guys were here, because I agree with you that the world of clothing needs to evolve.
Yes.
And if I remember correctly, you guys were looking for ways to create them, take the algae from the ocean, right? Do what you do, your secret sauce.
Yep.
And out comes a material that can go into a manufacturing facility that is today making t-shirts or pants or whatever, and they will have to do either minimal or no change to their process to use your materials versus cotton or whatever else, bamboo they may be using, right? Can you go over that real quick before we get into how you pivoted? Because I think that, although I think it's wise that you took a step back, because it is a challenging market. It is a very margin-driven market,
Very much so.
Yes.
right? You have a lot of competition from all over the world, but it's still a market that someday someone should tackle, hopefully you guys, right? So talk a little bit more about that in how much you went through that process of not just t-shirts, but also, I remember you guys were talking about, clothing for firefighters, right?
Yeah.
Talk a little bit more about that.
Yeah, I mean, so one of the things we realized kind of going through the gambit of trying to tackle the textile industry is one, textile industry is built on supply chain. I mean, the crazy part is, I mean, we talk to some of the biggest companies, I mean, Ralph Lauren, I mean, you go down the list, Reebok, Nike, like they're gigantic companies. And you quickly realize that the design hubs are here in the United States. The manufacturing is done in either India, Bangladesh, or China. Then that manufactured components get shipped all across the sea to maybe somewhere in Turkey or Thailand, where then they're doing cutting and sewing. And then they're shipping all those garments again to another facility to go through final quality control, and they're shipping it one more time to finally get to the retailer where you're going to your Macy's or H&M or wherever you're going to actually buy your products. And understanding that kind of dysfunctional supply chain was really interesting. And it also just told us the difficulty of trying to innovate in that space, because you have to get a lot of people, a lot of different groups need to agree, because you can get the buy-in from the brand. Let's just say like a Nike, for example. You can get a buy-in from a Nike, but then you have to go through their tier 1 to tier 2 suppliers, and you quickly realize that the textile mill that's been around for 100 plus years is, they've been working with cotton or they've been working with synthetics, and they're like, what is this algae material? We don't want to touch this algae material. It just makes it very difficult for new innovation to be sparked in that industry. But overall, I will say that there is an avid push right now from the industry to change, just because they're getting looked at under more of a fine-tooth comb with more of a stronger microscope, as you would say. So there is an active, I would say, push to change, but truthfully, it's going to come from consumers. The brands listen to the consumers. And at the end of the day, if you're a consumer and you go to, again, a Macy's and you see a t-shirt that is $20 and you see a t-shirt that is $30, they're the exact same t-shirt. One was made slightly more sustainably with less water or is a new material. The sad truth is majority of customers will go with the cheaper product, and that's still the problem that today. And if that exists in the world that we exist in right now, or if that continues to exist, the brands aren't going to switch. They're not going to do anything until there's either a serious regulation to do so, which is coming down the pipeline, but there's always loopholes around those. And the second part is actually the consumer. The consumer is the biggest deciding factor. I mean, you choose with your dollars. And I think that is starting to happen, because you're seeing companies like Allbirds over the past 5 to 10 years skyrocket in their development compared to the Nikes and Lululemons of the world.
Yeah, and I think to add to that as well is, I think we've realized, and I feel as a startup, you want to accept the world as it is, not what you believe it should be. And if you operate in this realm of you think it should be like this and you're operating in that realm, then you may not find the success that you would have if you just accept the world as it is. And what's really important for customers you want to tackle as a startup, and this is something we learned, is it's not only about, you know, the customer saying, hey, we have this problem, we want this algae-based fiber because it helps us, because of the lower water use, whatever that may be, it can replace cotton. But also it's the ecosystem that exists is super important and pivotal in order for you to actually penetrate the market. So for instance, in the fashion industry, to Derek's point, when we look at, let's say, the top brands in the space, right? They're all set up this way. They have an innovation team, right? This innovation team, there's someone hired to say, hey, go find the most innovative stuff in the market, bring that to us, and let's try to commercialize this. And like Derek mentioned, we have worked with these large apparel brands, and we met the innovation team. The problem with the large apparel brands is the innovation team is made up of maybe 5 to 10 people. As opposed to an innovation team in, let's say, the automotive industry, you're looking at a team of engineers of 200, 300 plus people. Yeah. And the problem with that is when you have such a small innovation team, their job is to find these new materials, but if they can't get the buy-in from the suppliers to integrate it, then their job is always to find innovation, and they're doing their job, right? They're searching for innovation. But actual integration of that, that's not necessarily their job. And from the supplier's point of view, what was very interesting back in COVID, we had an overabundance of supply in the textile industry because spending was cut. And the spending that got cut the largest was discretionary spending, i.e. clothing, right? Except in the luxury category, that actually did pretty well, surprisingly. But it's discretionary spending. So what happened is the textile industry and all the suppliers in Sri Lanka, Bangladesh, Taiwan, they had an overabundance of textile supply that wasn't being purchased, that was intended to be purchased, but it wasn't. So now, right, this is all like macroeconomics at this point, because now they have a ton of supply that they need to push. And then they're being told by the innovation team at Nike, hey, we want to introduce this new recycled textile or this new bio-based textile. The suppliers are like, no, we have all this inventory that we need to push. We're sitting on this sunk cost. So it's such a high friction environment for them to integrate the solution because they're sitting on all this inventory. So all that to say is the ecosystem is so important when considering the market that you're trying to penetrate. And we learned that firsthand, that the ecosystem just wasn't as strong as it needed to be as a beachhead market, right? That's not to say this isn't an opportunity in the future, but startup is all cash flow, how much money you got to the end of the year, and you need to make decisions where you can capitalize and grow quickly as opposed to a market that you can't penetrate for many years.
And that even applies even if it's not, you mentioned the example of 20 versus 30 for a shirt, for example. Under those conditions, even if your product is cheaper, they still have that issue of that sunk cost. They still have all that product that they have to push. They still have to recover some of that somehow, right? So even if you are able to provide something that reduces the bottom line for them so their margins grow, you're still fighting an uphill battle.
Oh yeah, and not only that, I mean, the funny thing is for natural materials or new more natural materials that are truly better for the environment and or better for the end consumer, is there's a different, let's say, technical or rubric that they evaluate. There's a different evaluation criteria. So they want the new material to be cost competitive. They want it to be outperforming the originals. They want it, like there's a long laundry list of all these amazing things they want this new material to do. And people don't realize plastics have been around for 70 plus years. We've had amazing engineers over the past 70 years develop it. The Rutherfords, the developers of nylon. I mean, these have been innovations that have been built upon and incrementally increased in efficiency by 1% every single year. So plastics today as an engineering material it's an amazing feat of engineering. It's just the fact those engineers many, many years ago couldn't see the future of, how consumerism would change and how these materials wouldn't degrade in the environment. So from that, it's a much more difficult to integrate a new technology because the brands do not want to sacrifice on their brand image by introducing a new product that isn't the highest performing, best product on the market. If there's just a slight bit of imperfection or inefficiency, or it doesn't meet the exact same specs, even more, then they're not going to put it on the shelf. And that's what hinders a lot of innovation in this space. Because we've worked, for instance, about a year and a half ago, we went to an event called Biofabricate, which is pretty much the world's largest biomaterials conference, where you have the largest manufacturers, again, the Nikes, the Lululemons, the biggest companies in the world, and you have all the innovative startups that are working on really crazy stuff. I mean, people that are sucking CO2 and turning that into either a polyester material, or people that are using mushrooms to make leathers, or using all these new amazing natural materials. But one of the biggest bottlenecks is the brands are really afraid to put their name behind it because they don't want to go to market and it just flops. So they would need such a long, stringent amount of testing to get something into the market that a lot of these startups just end up dying before they can ever see that kind of final crossing the finish line, if you will.
So very interesting. So you're learning some lessons at a very young age that a lot of adults never learn. I don't know if you're cognizant of that, but this idea, if you go in the world of mental health or therapists, they talk about eliminate the word should from your vocabulary, because that is not the healthy way of looking at the world. And you said something about looking at the market, looking at the world, not the way it should be, but the way it is. You see people talking about that is the isness of the world, is the isness of the people in the world, right? So you're learning these lessons, like you said, trial by fire.
Yeah.
And I think that's a beautiful thing for everybody that's watching, because that is, at least it's been my experience, whether it's in business or your personal life, that the world is the way you choose to see it, right? You know, there's no objectivity at all.
Yeah.
You know, even our two eyes don't see the same thing.
Yeah.
You know, the image in our brain is a correlation, right, of what this eye sees and the other eye sees, and then it's the combination of the two. So two people can only hope to come to some level of agreement, but not a complete overlap of understanding. So this is wonderful. So that led you to then pivot again.
Yep.
So what exactly does Source do today, in more of like, how does what you do today affect or will affect the lives of, you know, everyday people day to day?
Yeah.
So I think a good way to frame this is if we look at the world today, the biggest industries that are growing. So if we look at electrification of vehicles, right? That's a very strong growing industry. Aviation, they have goals over the next 15 to 20 years to drastically reduce the weight of these vehicles to make them more fuel efficient. If they're lighter, that means you can go further with fuel. So pretty much materials today, a lot of companies have reached a limit as to what these materials can do for society, right? We need stronger, lighter, cheaper materials. And we also need it to be secure from a supply chain perspective. We've learned a lot from COVID on supply chain resiliency. So when we look at materials today, right, let's just look at vehicles. We need materials that are stronger, lighter, so that these electric vehicles can actually go the range they need to go, right?
Yeah.
Range anxiety is so prevalent in a lot of people that purchase electric vehicles. So what has happened as of recently is a lot of manufacturers are looking into this world of nanomaterials, right? This is like the big buzzword. So AI is the big buzzword right now in software. Nanomaterials is the big buzzword in the material science field. And essentially what a nanomaterial is it's typically something that is extremely, extremely small, right? We're talking, 5,000, 10,000 times smaller than a human hair. But the wonder of nanomaterials is you can add just a little bit of it to, let's say, like a cement or a plastic or whatever other material. You can just add a little bit and you can boost the strength of that part immensely. Amongst other things, you can make it more flame retardant. You can make it dissipate heat better for like a battery enclosure, right? So manufacturers are looking at the world of nanomaterials to augment the current materials they have today. The problem with this, like Derek mentioned, is the go-to nanomaterial is something called graphene. This is something made from carbon, right? So think of like charcoal. So you take carbon and you cut it up into very, very tiny pieces and you get something called graphene or something else called carbon nanotubes. Very high strength material. And this is what the world sees as like, oh, we can make space elevators out of this stuff. That's how strong it is. It's the strongest material, lightest material on Earth. The issue with graphene and carbon nanotubes is, for one, they're very expensive, right? Like they can be $600,000 per ton, right? Which, for reference, carbon by itself or coal is like 100 times cheaper than that.
Yeah.
So it's quite expensive, but then the big issue with nanomaterials is they don't actually like to mix and play very well in the materials that we want to put them into. So almost think of it like oil and water. They don't mix together. That's the same thing with a lot of nanomaterials. They really don't like to mix that well, and that's incredibly important in terms of how well that nanomaterial can strengthen something. If it doesn't mix well, it's pretty much useless.
Yep.
So what we set out to do as a company, because we had experience with these nanomaterials and research, we set out to make a lower cost nanomaterial that still has very high strength and is compatible. It can mix with all these different materials like plastic or composites like fiberglass or carbon fiber. So what we do as a business is we convert biomass like seaweed or even hemp. So this is a lot of materials that are excess biomass, that they're not really being used for many things today. And we developed a process where we can take that biomass and extract out this material called cellulose, and then we reduce that cellulose to a size 10,000 times smaller than a human hair. something called nanocellulose. But what's interesting about nanocellulose is it's 8 times stronger than steel, but lighter than carbon fiber, which is one of the lightest materials on the market. So you have something that's high strength, very low weight, and what we do with that nanocellulose is we sell it to manufacturers so that they can put that into their materials, like, for example, carbon fiber reinforced plastics, so very strong lightweight material. They mix it in there, and they can boost the strength of that final material. We've seen by 30 to 60%, but our material only makes up 0.2% of the final weight. So what we're enabling for these manufacturers is they can actually meet the goals of making their parts stronger, making their parts lighter. Because what ends up happening is if they add our nanomaterial into their production process, they can make their parts stronger, which means they don't need as much material to get the same strength as before. So if we're still thinking in the scope of, let's say, electric vehicles, now you can make the battery enclosure lighter, which means you can make that vehicle go farther.
Yeah.
Or let's say in a windmill, right, wind turbines, you can make it lighter. That means you can generate more power because it's lighter, so you can generate more energy.
Yeah, you can spin faster. So just like in the next 5 years, what we see our innovation really kind of doing for society and the industry is exactly what Mason said. I mean, we're making electrification of vehicles possible, or more possible, I should say. You're making maritime shipping. I mean, in the marine industry, I mean, fiberglass is the #1 used component to make boat hulls. So, I mean, you think about trying to ship goods all across the world. Fuel efficiency is the #1 game there. So if you can just increase fuel efficiency by 1 to 2 to 3%, that's billions of dollars of saved goods when you're transporting these materials all across the world. So we really feel that definitely within the next 5 years, we see ourselves being able to incorporate these materials into these really high-end manufacturers that then trickles down to the end consumer, and the end consumer reaps the benefits of, oh, now I have a Tesla that instead of going 400 miles can go 800 miles. So now on one charge, I'm competing against a traditional gas vehicle now, and it may make the adoption larger. Same thing in the maritime or shipping industry. Okay, if we can increase the efficiency of a shipping vessel by, again, 2 to 3%, you're saving billions of dollars in logistics costs. So it's just kind of how it's a trickle-down effect of how starting so high in the supply chain can have such a massive impact across multiple different market sectors.
And when we think of impact as well on that point, what's interesting about the seaweed part, right, that's kind of the main one that we use, the feedstock we use. We primarily use seaweed called sargassum. So a lot of people in Florida have heard of this issue of sargassum showing up on beaches. Hotel chains are trying to get rid of this stuff. And we actually work with procurement companies where they're getting paid to get the sargassum off the beach from hotels and governments to give it to us so we can make this material. So you also have a large impact in terms of you're working with a supply that is a problem for society, and we're removing that and making a high value material out of it, which I think is the key thing, because a lot of companies can sometimes struggle trying to use biomass to make something when they try to make a low value commodity good.
Yeah.
It's a low value biomass into a high value material and chemical.
Yeah, and Rafael, you mentioned earlier about how did we pivot into the world of firefighting and fire retardant materials. So at one point we realized, okay, we could sell just this nanomaterial such as nanocellulose, but then we thought, well, what if we mixed other stuff into it? What if you used it as like a carrier vehicle or a kind of a material that can utilize other particles and get them onto surfaces? And that's kind of one of the aha moments that we had, where we were able to mix traditional ceramic particles into our seaweed juice and then apply those to textiles, and it made the textiles fire retardant without having to use any halogenated or brominated compounds, which are, for the more layman's terms, toxic chemicals you put on clothing so you don't catch on fire. And that goes down the laundry list. I mean, right now we're looking at, of course, fire retardant applications, but then as you mentioned earlier, in the world of textiles, one of the most ubiquitously used things is something called DWR, which is dry water repellent. So if you've ever worn a Gore-Tex or an Arc'teryx jacket or anything like that, I mean, they're using water repellents because you don't want to get wet. And those are made of polyfluorinated compounds, so PFAS, which is kind of the big buzzword a lot of people know. And these are the quote-unquote forever chemicals that even today, there's studies are starting to come out where Micro and nanoplastics and even some of these small polymers are starting to pass through the blood-brain membrane, which is now you're starting to see plastic in human brains. You're starting to see plastic in fetuses of women that the child hasn't even been born yet, and the woman is passing on these harmful chemicals to them without ever even knowing, just by coming in contact with certain surfaces that they don't realize. One of the things that you learn, I guess, in the world of material engineering is everything is coding. Whether you have a t-shirt, it's coated. This wooden panel is coated. The fabric, the walls, everything has some sort of coating on it to allow it to perform. And we've kind of turned a blind eye to that over the past 50, 60 years. And it hasn't. Now, of course, science has started to catch up to us, and we're starting to realize, oh, those things that we were spraying on all these materials are starting to have adverse effects on a variety of health aspects. And now we're in that window where the research is coming out, and we're starting to learn about it. And there's a doctor where she actually published a whole research paper about male infertility. So one of the largest things is males are actually becoming more sterile due to some of the underwear that they're wearing or some of the things that they're consuming. And that's a pretty terrifying fact. If you go out 50, 60, another 100 years, I mean, we may not end from a nuclear war. We may end by just sterilizing ourselves via the chemicals that we come in contact on a daily basis, which is kind of a terrifying thing to think about.
The interesting thing about that, and I know we've talked about this, is there's two ways to look at the problem. I mean, for me, it's a win-win-win no matter how you spin it. But we live in a world where at least the powers that be are only looking at eternal growth, right? I was having a conversation a few weeks back with someone. The corporate world behaves like a cancer.
Yeah.
What else in nature expects to grow quarter to quarter forever? I mean, so if you're a company and Wall Street is expecting you to grow quarter to quarter forever, eventually that means you're going to take over all your competitors.
Yep.
Globally, right? And then there's nobody else. And then what? Well, you start, going to other galaxies. I mean, how do you do this, right? So there's that pressure, right? But what you're doing has an immense value from an environmental consciousness point of view, of being conscious about the environment. You're using algae, and algae that is actually not liked, that humans want to get rid of because it causes problems for their business, right? And if you wanted to grow that, you probably could grow it too, right?
Yeah.
You can have algae farms.
We work with farmers as well, yeah.
Exactly, right? So no matter how you spin it, you're reducing cost, you're removing toxic chemicals for things that we wear and use every day. It seems to be that you found a sweet spot on the pricing there, right? But you still have to be careful, because depending on who you talk to, if you come with the angle of we're trying to save the world, you lose certain members of the audience immediately. But if you don't say that, then you lose the other side of the audience, and that must be a challenge for you.
Yeah, it's a double-edged sword.
Yeah,
And the word sustainability is different for every individual and is different for every single company. That's one thing we realize. I mean, you go to one business unit in an organization, sustainability to them is water reduction. Then you go to that same company, to a different business unit, and sustainability for them is, we use less plastics, or we're able to reduce the amount of material we have to produce and make the same amount of money. So there's no hard definition on what sustainability is for somebody. And again, it's different for every single organization, almost every single person, depending on how they define it.
Very interesting. So we have about 10 minutes left, and I didn't get to cover all the things that I wanted to cover, but I think this has been very, very interesting. Where are you going next?
Yeah, so I mean, right now, we're in that process that every startup trying to build a crazy business is going through, which is growth. So, we went from having a team of just Derek and I and our co-founders to now we have a team of, I think, around 11 people now, ranging from all different facets, from material engineers, chemical engineers, computer engineers, sales. Now we're at the point where we are starting to grow and 2 labs in Lake Nona in the Guidewell building. And like pretty much on a daily basis, we're trying to see how we can push the limits of production and produce more. Because a lot of the clients that we work with, now we're shipping larger and larger batches.
Yeah.
So we're at the stage where it's like, okay, like we have to level up here in order to service the clients that we're having. So pretty much what's next is we're planning on launching a new facility, fingers crossed, later this year. We'll be increasing our production capacity from around 100 kgs a year to 1 ton, so 1,000 kgs. And that will allow us to work with the different customers along the supply chain. And we work with customers across the aerospace industry. We're working with the automotive company now. So really going into high-value technical markets. And now we're at the point where we're growing the team. So we're bringing more smart people a part of the program to really build what we're trying to build, which is the first global production facility for nanocellulose. And that's our mission as a company, is be one of the largest producers of nanocellulose into these very high-grade technical markets.
Yeah, and in the future, I think this is a really cool, just kind of full cycle story. Whether you believe in evolution or not, I mean, the idea is we come from the ocean, we came from the ocean onto land and then developed how we developed, and I think it's kind of funny that in the near future, we're utilizing seaweed, and seaweed will be in space. I think for our applications, we're working with a couple companies right now where if they integrate our material, it makes their components lighter, and you're going to see seaweed nanomaterials on satellites, seaweed nanomaterials on rockets, and even seaweed nanomaterials on things that land on the moon. And I think that's going to be a really exciting future that we can all kind of strive for. And another thing that I think is coming down the pipeline, and this is more of just I guess a personal opinion or something that we have to look at quite critically, is the world of AI is coming down, and it's coming very quickly. And the world of robotics is growing quite fast. I mean, there's a couple companies that we know and work with where they're developing. I mean, if you've seen Iron Man, they're building Jarvis. Like within the next 5 years, we'll be able to walk into our home and say, "Hey, Jarvis, I need you to make the chicken for me and turn on the TV and warm up the car because it's cold outside." And I think, and to your point, Raphael, of like how do we start to shift not only the corporate business world, but also the social aspect of it. How do we treat and look at society? I do think there's going to come a day quite in the near future where we have to really look at ourselves kind of look at ourselves in the mirror and say, okay, how are we going to change the system that we have today? Because these overall technical advancements are happening at such a rapid pace and so quickly that I don't know if society is ready for that such a fast shift. Because it is a pivot that is coming, and it's coming fast. This is just what we're seeing in the material science space. I mean, we're talking to companies that what would take them to formulate a new cosmetic or this is a very trivial example, but a new cosmetic, which would take them almost 6 to 9 months to do, they're able to do in 3 days, 4 days with artificial intelligence. Now you've cut out time, you've cut out the people that do those jobs, and there is going to come a day where a billion-dollar, a multi-billion-dollar company is 8 to 10 people and software. And that's going to be a really interesting time period because we're going to have to learn how to redistribute the wealth that is generated from that. And I think that's going to be a very interesting time period.
Well, it's we're already seeing some of that, right now, and it's interesting when you have companies, young companies like like yours, and you enter conversations with people about the environment and how we need to save the earth. And I smile, not in a negative way, but I tell them, the earth's going to be fine.
Yeah,
We're the ones that are going to not be here.
Yeah, we'll be gone.
Yeah, the earth is going to be fine, and we just need to figure out how to really become better global citizens and get smarter, and like you said, redistribute so that it's for the benefit of all. So it is encouraging to see the work that you guys are doing with such a small team, and the fact that you're so young. You could be my kids. my daughter is turning 26 this year. So
you probably had some classes with her.
Yeah, so no, it's very, very interesting what you guys are doing. Where do you think people will see your product first in everyday households?
If you're a big golfer,
Yes.
You'll
Well,
see-
not
Not
right now.
now.
Not right
Yeah.
now, but yes.
one of the areas we're focusing very hard in right now is in the sports equipment space. So think of golf clubs, surfboards, paddle boards, board sports, snowboarding, skis. That is a very direct area. So we're working with a couple companies in that space, which is quite exciting. We're really pumped about. And I think on some of the larger areas will be in the automotive sectors and aerospace sectors in the next 5 to 10 years. But I would say first is definitely going to be more of your sporting-based equipment.
Yeah, I mean, 100%. Like, I mean, that's a market that we really hold true and near to our heart because, I mean, we also played sports when we
Yeah.
were much younger. And it's just such a cool area to see how consumer products, specifically sports equipment, how innovative they can really be. And I think that just gives them a competitive edge as well. If they're introducing this nanomaterial golf club, right?
Yeah.
Like, it just sounds cool. But also, I think it's cool for us to see this with our background in material science, to see something that actually is going into the world and being used. And I think what's most exciting is, nanomaterials is this space that hasn't really reached the masses for many years. And it just feels like we're really at that inflection point where the technology exists today to actually do it. And I think we've developed a process to make it more feasible. So I think we're actually going to the world because we read about materials like nylon and Kevlar back in school, and we thought, wow, like the people that put that together, it's insane, and they're part of history. So it's just interesting because we don't know if the time we're in right now, if we're successful 5, 10 years from now, we may be able to look back and say, yeah, our team, we were one of the people that were able to make nanomaterials on a mass global scale that people work with every day in their everyday production process. And I think that's what really excites us a lot.
Yeah, and I think bringing back or reinvigorating the manufacturing and the ideology of like build things again. I think in the early days, the U.S. was built on risk takers. I mean, you talk to anybody and they're willing to take a risk to build something. And I think over the past maybe 30, 40 years, that got lost kind of in the weeds of development and to your point of maximize profits at all costs. That I think we're kind of seeing a shift now in the American concept of, okay, we need to be able to build things. I mean, if we can't build things, then it's going to make it very difficult for us to be a global player in the future. And I mean, today you're seeing manufacturing such as advanced semiconductor manufacturing being built here in the Orlando area and Arizona. I think the time period is now. I would say there's the ideology of building an advanced nanomaterial company in the U.S. is very possible. And there's also a big incentive right now to establish American manufacturing or securing the supply chain for the future to come.
Derek, Mason, it's incredible what you guys have done. I'm sure your parents are very proud. Thank you. Thank you
They
for
weren't in the
being here.
beginning, but yeah.
Well, but you've done, I'm honored that I was here when you guys got started here at LEAD to see what you guys were doing and all the experiments that were going on over there in the back.
Yeah.
Thank you for being here. I hope we can do this again sometime.
Yeah, thank you for having us.
Thanks for having us. We like the work that you do. I think it's very important to shed a light on the small innovations and the cracks and crevices in Orlando and just everywhere. I think the work you do is very important.
Excellent, thank you. And for those of you online, we have about a 10-minute break and then we have our next guest. Please don't go away. Thank you.
Thank you. Yay.
Thanks.